All right, now we have the x and y axis. Now imagine an angle whose vertex is at the origin. We'll put a vertex. And pretend my pen here is the beginning of an angle, and the vertex is right here at the origin at 0, 0. Imagine an angle just moving this way, and this pen actually being where the angle stops, and the x-axis being the beginning of the angle. Notice how my pen can just go around, become 360 degrees, and stop at the x-axis again. So an angle whose vertex is at the origin, and let's say stops anywhere. Anywhere. This angle that's formed, this part of the angle is called the terminal side, where it stops. Go ahead and put that on your notes. And where it started is the initial side. Okay, so we got a terminal side and an initial side. Okay. So you're copying this down on that handout I gave you. A terminal side and an initial side. If you have an angle that looks like this where the vertex is at the origin, now when I say origin, that means the point 0, 0 here. Okay? If an angle's at the origin, this is the terminal side, this is the initial side where it started. This angle we call, we say in mathematics that this angle is in standard position. But the angle is in standard position. So the vertex is at 0, 0. That angle can just keep going around in revolutions. Around and around. And wherever it stops, we call it the terminal side. And here's your angle right here. In the space in between the x-axis and the terminal side is your angle. Now that angle can stop in the second quadrant. Remember that game we played of tic-tac-toe? The third quadrant, the fourth quadrant, and so on. All right. Now, moving right along. Let's go up to the top of your note guide, and you see this picture. Okay. Now, when we talk about angles in standard position, like say this is 0, 0 right here. Go ahead and put that on your notes. Put this point in 0, 0. And let's pretend this angle, here's your terminal side, and here's your initial side. This arc length, this part of the circle right here, okay, on your paper it's right here, from here to here, it's highlighted. If this arc length, if this angle goes up and stops here and intercepts an arc that's the exact same distance as the radius, then we call this arc distance 1 radian. This would be, actually not the arc, but the angle would be called 1 radian because it opens up to a point where this arc is the exact same distance as the radius. So go ahead and write arc is exactly the same distance as a radius. Okay? That's what a radian is. So right now you got to focus because we're going to start talking about radians from here on out. We're not going to be talking about degrees of angles. We're going to be talking about radian measure. And when you get to calculus and the higher maths, they don't talk about angles and degrees anymore. They measure them in radians. Okay? So 1 radian, okay, 1 radian would be an angle where this arc is exactly the same distance as the radius. So this radius was, let's say, 10 inches. From here to here, this arc would also be 10 inches long. This angle would then be called 1 radian, a 1 radian angle. Okay? Where the arc is exactly the same size as the radius. Okay? Now looking at the bottom right here, on this picture, it kind of gets into what radians are. Look at my picture up here. Move this out of the way. So look what you got here. So look at an angle that's 1 radian large. Look at this arc is the exact same distance as the radius. Let me see. How about 2 radians? Well, look at this arc is actually 2 radiuses. Look at this radius. However however big this is, it's twice this arc. That would be 2 radians. How about 3 radians? Well, look at 1, 2, 3 radians. Look, so whatever this radius is, now multiply it by 3. That's 3 radians. So 1 radian, you're thinking, is an angle where this arc of the circle is exactly the same distance as 1 radius. Okay? So far so good. Look at, here's 4 radians, 5 radians, 6 radians. Look at 6 radians is almost a full circle. And then a little bit more would be 1 revolution, which would be 360 degrees. And on the picture on the handout, it kind of gives you an approximation of how many degrees each radian is. If you want to stick with degrees, because you're more familiar with degrees, notice those are the degrees of each angle. Okay? Now, that's what this picture is. Go to flip your page to the other side. So look at the bottom right, you have this picture. This kind of gives you an idea of common radian measures. Notice how 30 degrees is actually pi over 6 radians. Now, where does pi over 6 come from? Pi over 3? What the heck is that all about? That's what I'm about to teach you. So, say again?
I've seen this before.
Yes, it's very common. The higher math, you're dealing with radians all the time. This is where the calculus comes in.
I've heard a fellow of my head classmates say they had to memorize the entire
Yeah.
for a quiz, like a little quiz.
Right. That's very common. I'm not going to make you memorize it though.
Okay.
I'm just going to familiarize yourself.
I had a very mercy.
Now, let's get back to basics though. 1 radian, an angle that's 1 radian would be an angle that would intercept, that would capture an arc the exact same distance as the radius. That's all. I want you to just soak that in. Imagine an angle, look at opening up and stopping here, and imagining this part of the circle being the exact same distance as the radius. That's 1 radian. 1 radian. Now, how do we go from degrees to radians and from radians to degrees back and forth? You guys are more used to degrees. That's all you've been taught up to this point. Oh, that's a 90-degree angle. That's 60-degree angle. 180-degree angle. How do we go back and forth from radians to degrees? That's what I'm going to teach you right now. So here we go. Example 1. All right, example 1. Convert 30 degrees to radians. Go write that. So now on a separate sheet of paper, put example 1. You might want to put it, if you can fit it on here, that's fine. I'll recommend on a separate sheet of paper. But write, convert 30 degrees to radians. Degrees to radians. So here's the solution. Right now is a bad time to fall asleep without this. To convert from degrees to radians, multiply, ready, by pi over 180 degrees. To convert from degrees to radians, multiply by pi over 180.
To go from radians to degrees, you would divide. From degrees to radians.
Right,
Oh,
this
so
is
just saying if you were to go from
right,
radians to
degrees, we'll multiply by 180 over pi, the reciprocal of it.
Oh, okay.
You see what I mean right now, watch. So, our mission right now is to convert 30 degrees to radians. How many radians would that be?
0.
Let's see. I'll take 30, okay, 30, and I'm going to multiply it by pi over 180. Okay, let's do it. Remember, this is why I had you multiply by fractions for a warm-up, just to review. How do you make 30 into a fraction?
Put a 1.
Exactly. So watch this, numerator times numerator. 30 times pi. I'm just going to leave it as in terms of pi right now. When we talk about radians, we always leave it in terms of pi. We could approximate and then replace pi with what we noted to be for the 3.14, right? But mathematical good manners and the convention is, if you're ever going to talk about radians, you always leave it as pi, your final answer. Don't replace it with 3.14, unless you're going to approximate the angle. Just leave it as pi. So right now, the numerator is 30 times pi, so you got 30 pi over 180. Okay. Let's simplify the fraction. 30 and 180. There's a number that fits into 30 and 180. 3, huh? 3 fits into 30 10 times. So I wrote 10 pi on top. 3 fits into 180 60 times. Let's keep going. I'm going to leave it as a fraction, but simplified. 10, 10 goes into both, huh? 2 does too, but it'll take longer to get the final answer. I want to go, the bigger the better for reducing. So 10 goes into 10 once. So I have 1 pi over 6, huh? So my answer is pi over 6 radians. Pi over 6 radians. So 30 degrees, if I want to convert that to radians, it's actually pi over 6 radians. Now what the heck does that mean? Let me show you what that means. You see that? It's on that table, huh? So it's on the lower right. 30 degrees is equal to pi over 6 radians. But, so what? So what the heck does pi over 6 radians mean? Well, look at what it means. Check this out. Remember how I taught you that 1 radian would be an angle where the radius is exactly the same as the arc. So this is the exact same thing as this. That would be 1 radian. I'll put 1 RAD. If that's 1 radian, 2 radians would be about right here. 1, 2. 3 radians, 4, 5, 6 radians. So remember, 1 radian is where this is exactly the same size as the radius. So 1 radian. What would pi over 6 radians be then? Let me take 3.14 divided by 6. Watch. Watch this. 3.1, how much does it take to get pi? Pi divided by 6.52. So that means, so 0.52 radians, that means it's not exactly 1 radian, it'd be about half of it, 0.52 of it. So if this is 1 radian, 0.52 is about half, because 0.5. So 30 degrees would be about right here. Half of a radian. You see. Okay, so that's pi over 6 radians. Let's try another one. So right now I'm just teaching you how to go from degrees to radians. Example 2. Convert 40 degrees to radians. Convert 40 degrees to radians. Stay with me, Chris. So 40, if I want to go from degrees to radians, I'm going to just multiply by pi over 180. So 40 times pi over 180. Okay, let's do it. 40 over 1 times pi over 180. So I really have 40 pi over 180. Let's simplify the fraction. Let's go, how about 20? Yeah. 40 divided by 20 would be 2 pi. 180 divided by 20, 8. Wait, what did we?
Wait, no, 9.
No, 9.
Yeah, it's not like that.
No, that's fine. I'm not good with numbers either. Done. 2 pi over 9 radians. There it is. So 2 pi over 9 radians. Okay. Example 3. Convert, now we're going to go from radians to degrees. Convert pi over 2 radians to degrees. How many degrees would be pi over 2 radians? An angle that's pi over 2 radians. How many degrees would it be? 90. So he's just looking at the table, huh? I like that. Well, let's figure out how the tables came to be. So what we'll do is we'll take pi over 2, and we're going to convert it to, we're going to multiply by the opposite of, or the reciprocal of pi over 180, which is
180 over
180 over pi. So to go from radians to degrees, it's 180 over pi. To go from degrees to radians, it's pi over 180. Okay? Look what I got. Fraction times a fraction. Remember on warm-up, we can cross-cancel. Look at the pi's cancel out. So I have 180 divided by 2, which is 90. 90 degrees. And notice, look on that table on the lower left. 90 degrees is actually pi over 2 radians. You can see that. They got the equivalencies there. One more example. Easy day. That's all I'm going to teach today is how to go from radians to degrees and vice versa. Okay. Convert, this is number 4. Convert 2 pi over 3 radians to degrees. Two pi over 3 radians to degrees. let's do it. So 2 pi over 3 radians. So I'm going from radians to degrees, so I'm going to multiply by 180 over pi. So I got 2 pi over 3 times 180 over pi. Exactly. So how many degrees would this one be? Well, so 2 times 180 is 360 divided by 3, 120 degrees.
Pretty easy stuff.
So the main thing I want you to remember is not only how to convert, but what the heck is a radian? A lot of students will get confused on what a radian is. And it goes back to what I initially said. Imagine an angle opening up where this distance right here is exactly the same distance as the radius. That would be 1 radian. So it's like a way of measuring angles different than measuring with degrees. In other words, I can measure the distance between me and Nunez in feet or in inches, different units of measurement. So in the same way, I can measure an angle with degrees, like this would be maybe, it looks like 45 degrees to me. I could be off a little bit. I can measure in degrees, or I can measure it in radians. See, this would be exactly 1 radian, this angle. 1 radian large, instead of 45 degrees large. So it's just a different method of measuring an angle. That's more useful when you get to higher mathematics. I'm done for the day. If you were not here on Friday, quiz 6. Quiz 6, you owe me quiz 6 if you were not here on Friday. Okay. If you're done with quiz 6, we still have assignment 9 and 10. Just let me finish, you guys. Hold up. Work together, work solo, it's up to you, but make sure you're being productive so I can give you your stamp. Let's get busy. We have about 20 minutes left.
I mean, yes, because it's hard. So, yeah, it's just quick 6, right? Oh, yeah, right.
I got you.
Yeah.